Okay, so this video is about the midterm 2 review and for the lecture on March 30th, 2020. Okay, so here I'm going to review all the questions that I posed for midterm 2 review. I go over all questions one by one. Okay, now start with the first question. The first question is to review a little bit about the dot product and cross product for two vectors. Okay. So the first question is, if I give you two vectors, A1 is 2, 1, 0, B vector is 4, 2, 3, compute the dot product and the cross product. So dot product A dot B is the entry-wise product between the two, which means the product of the first two entries, first entry of A and the first entry of B, and the product of second entry of A and the second entry of B, 0 times 2. And last one is 1 time last entry, the product of last entry of A and the last entry of B, which is 1 times 3. So then we compute the plus, the sum of all the products, which give us 2 times 4, which is 8, plus 0 times 2 is 0, 1 plus 1 times 3 is 3, so which gives us 11. Now the cross product is given by A cross B, so it is computed by computing a 3 by 3 determinant, and so the first row of my this 3 by 3 matrix is given by I, J, K. Now the second row for the matrix over here is given by A, whatever A you have. We have 2, 1, 0, okay, and B will be last row, so it's 4, 2, 3. So this one we can compute it as something time I plus something time J plus something time K. Okay, so the after calculation, I don't talk about how to compute determinant. After calculate determinant, you'll get this one will be negative 2. This one will be just also negative 2, and this will be 4. So then your cross product will be just negative 2, and 4. Okay. So that's for first question, first part of first question. The second question, third question is about the smallest angle between A and B. Okay. So basically for A and B, if I draw it over here, so A is vector if you using the 3D space. So I don't know how to draw it exactly. So 2, 0, 1. So if this is X, this is Y, Z. So 2x is 2, y 0, and z is 1. So you sort of have a vector like this, somehow like this. This is A vector, and B vector will be 4, 2, 3. This will be 4. Okay, I'm gonna this 2 and this 4. This will be 2 over here. 3 will be right over here. It's somehow like this. So there will be two angles. So one is this angle. You can talk about this angle, or you could have another angle which is just to the other side. Okay, right over here. Okay, so the smallest angle, as we mentioned, this angle A dot B is just A norm magnitude is and B magnitude time cosine theta. This will be angle. This, if you can see, this is an angle. This will be the theta angle. So this is given by this. The theta here will determine the angle basically, right? If theta is small, because this angle, this blue and red one, the sum will be like 360 degrees, for example. So if this guy is smaller, then it will be just theta, whatever theta you get it from here. Otherwise, it will be just 2 pi minus theta. Okay. Let's calculate this one. So A and B, so A dot B will calculate 11. Okay, so A magnitude is the square root of the square of everything. Okay, the square root of 2 plus 0 square plus 1 square. That's take a square root. That's the length of A times the square root of the B vector, the norm of B vector, which is 4 squared plus 2 squared plus 3 squared. Time cosine theta. So this will give us, this is 11. So this is square root of 5. This is square root of 16 plus 4, 20, 20 plus 9, 29. Okay, this is the cosine theta. So this cosine theta is 11 divided by square root 5 times square root 29. So this one, apparently this angle will be within 0 and pi over 2. Okay. So which means this is small angle because you do 360 degree minus that, it will give you larger than that. So small angle will be determined by cosine theta. So this theta will be just this theta, the cosine theta. The theta such that cosine theta will be 11 divided by square root of 5 then divided by 20 square root of 2019 will be the smallest angle. Okay, so in some special case, for example, if my cosine theta is 1/2, I know theta will be just pi over 3. Okay, if cosine theta is 0, now theta will be just pi over 2. If cosine theta is 1, so theta is just 0. So there are some special cases. Okay. Okay, last one. The cosine theta is square root of 2 over 2. Now theta will be just pi over 4. So there's some special case you can remember that. Okay. All right. Okay, that's for first question. The second question is about the computation of the derivatives of a given vector. Okay. So the second question, given vector rt given by which is et sine t plus t cosine t, the first entry of your vector, and second entry will be sine t divided by t squared. Last one is t squared plus 2. So derivative of rt also denoted by rt dot, which is the derivative of each component with respect to t. So the derivative first one will be, okay, a little bit complicated. So derivative first piece is the derivative of each component with respect to t. Derivative first one with respect to t is et cosine t plus et sine t. Okay, the first one. Okay, the second one is t is cosine t plus, it should be minus t sine t. So that's the first one. Okay, the second one is a little bit complex. Okay, also complex. What it does is, which is equal to t squared squared. Okay, there's a t squared, keep it unchanged, and you take a derivative of sine t, which is cosine t, and minus, you keep sine t unchanged, and your derivative of t squared, which is 2t. So put over here 2t sine t. So that's the second one. The last one is the derivative of this guy will be easier. So the derivative of t squared with respect to t is 2t, and derivative of 2 is just 0. So just say this is it. Okay, question 3 is about to find out the parametric representation of a line. Here we're talking about a straight line starting at a point P, which is 435, and ending at a point Q, -7, 2, 1. So a typical, this is a typical representation for a straight line. This is for straight line. It's just the starting point plus Q minus P is the ending point and minus starting point and time t. And when you let t start from 0 and ending at 1. So when t is 0, you know when t is 0, so you have your r's of t will just p. So rt is just p. So when t is 1, so when you replace t by 1, so it's a p plus q minus p times 1 will be just q times p. So p plus q minus p will be just q. So r sub t is q. And you can check because it's a straight line. It's a linear form, so it's straight line. In other words, we can represent this as 4, 3, -5 plus this guy q minus p will be just the minus of the corresponding entries. So it will be -7 minus 4, so minus 11, and 2 minus 3 will be -1. 1 minus -5 is 6 times t, and let t start from 0, -1. Okay, this is question 3. Okay, question number 4 is to compute the length of a curve. So let a curve be given by this form r sub t, which is 3 cosine t, 3 sine t, and 4t. Okay, and have starting t starting at starts at 0 and ends at 4. Okay, I want to compute the length of the curve. So length of the curve, if I use S to represent the length of curve, is given by the integration of, if t starts from 0 to 4, you just t to 0, starting 0 to t to 4. So inside this one, the square root of the derivative of each component. So it will be just 3 cosine t. You take a derivative with respect to t. It's d3 cosine t and dt, and you take a square of that plus d sine t. The second component is 3 sine t. 3 sine t and dt, you take a square root, and plus last one, d is 14, like last entry, dt, you take a square root. Okay, so you integrate over dt, that's what we have. Okay, so it's just a derivative of each component with respect to t, and then you take a square of that derivative, and you compute the sum of all the squared, and then take a square root of that, and integrate over the time interval we have. Okay, if you do this one becomes 0 to 4, so square root of the derivative of this guy will be 3 cosine t over dt is negative 3 sine t. You take a square, it will be just 9 sine t squared. And the second one is 3 sine t, derivative with respect to t is 3 cosine t. You take a square, is 9 cosine t squared. And then 4t over derivative of 40 over t is 4. 4 squared is 16. Okay, times dt. So this will give us, let's go over here, which is 9 sine t squared plus 9 cosine t squared, which is 9. This will be just 9. 9 plus 16, 25. 25, take a square root is 5. So 0 to 4 is 5 dt. Okay, so the integration of 5 is 5t. 0 to 4, so let's give us 20 minus 0 is 20. So the integration, the length of the curve is 20. Okay, so fifth question is about compute the velocity, acceleration, the speed of object if given the position of the object at different time t. Okay, so here r of t given by 3t t squared t cubed minus t represents the position of a moving object at different time t. So velocity of rt, the first question to compute is the velocity v sub t at t2. So first step is to compute what is the v sub t. So v sub t is just r derivative, the derivative of r sub t. Okay, here's the true one t represents the time. Okay, so derivative of this one will derivative of each component. So derivative of 3t with respect to t is 3. The derivative of t squared with respect to t is 2t. The derivative of t cubed minus t, right, which is 3t squared minus t derivative of t is 1. Okay, so here we have, if we do right over here, it's so then we can replace t by 2. So 1t, my velocity is, just replace everything by 2. Okay, so the first one doesn't matter, it's still 3. The second one is 2 by 2 is 4. Last one is 3 times 2 squared. 2 squared is 4. 3 times 4, 12. 12 minus 1 is 11. So that's the velocity at 2. Okay, so acceleration at t is 2. Acceleration is, let's compute the first acceleration first. Okay, which is the derivative of v sub t. Okay, so what to figure out v sub t? We just take one more derivative of that. The derivative of 3 over t is 0. Derivative of 2t over t is 2. Derivative of 3t squared minus 1 is the derivative of the first one, 3t squared, which is 6t, and the second one is 0 because it's constant. Then we just replace t by 2. Okay, this acceleration is 0, 2 doesn't matter, they do not depend on t, and 6t is t is 2, which gives us 12. Okay. Last one is calculate speed at t is 2. The difference between speed and velocity is speed is only how fast we're moving. It doesn't matter its direction. It's point backward or forward. So only the magnitude. So the speed is just the magnitude of my velocity, okay, at my time 2, right? So here's t is 2, which is the same as v2. We take the magnitude of that one. Then vt is already calculated over here, which is 3 and 4, 11. So it's just the length of my 3 and 4, 11. Okay, which is the square root of 3 squared plus 4 squared plus 11 squared. So which is square root of 146. Okay, the question number 6 is about compute the gradient of a scalar field. So if you're given a scalar field f, which is 2xy minus 3y squared times z, which is given a scalar field, for meaning that for different x, y, and z, I can define a scalar associated with the x, y, z. The first question is to find the gradient of f of this scalar field. So the gradient of f is given by push f over push x times I plus push f over push y j plus push f over push z times k. Okay, which is taking a partial derivative of this scalar function with respect to x, y, and z. With respect to x, okay, so for the first term with respect to x, partial derivative is just 2y, and the second one is not a function of x, so the partial derivative is just 0. So this is the first one. The second one is partial f over partial y, so the first one is partial y is 2x, the second one is minus 6. You consider z to be a constant, so the derivative will be just negative 6 times y z. Okay, so this will be j plus k is partial f over partial z, and the first one is not a function of z, so it's 0. The second one is the partial derivative is, we consider y to be a constant, so it's negative 3y squared times k. So this is the gradient. The second question is to find a unit length vector that points in the direction of the maximum increase of f, x, y, z at this point. So here's one key concept is the direction of the maximum increase of this scalar field is actually given by the gradient. The gradient gives the maximum increase of the scalar field at any point. So by knowing that, we can calculate this gradient. We just have to figure out first what is the gradient when you have this point, which means x is 1, y is 2, y is 1, and z is 2. We're trying to figure the gradient. That gives a maximum increase. But here also we have to find the unit length vector. So we just, once we figure the gradient of that one, we just find the unit vector associated with that. So that will be done. Okay, so we already figured out the gradient right over here. We just have to replace all the numbers there. So, which means 2y, so y, 2 times y, so y is 1. Okay, over here, so it's 2i. So, plus, the second one is 2 times x. Replace x by 2, so 2 times 2 minus 6yz, y times 1 times 2. Okay. J plus negative 3y squared, y is times 1 squared. Okay, so which is give us 2i minus, this is 4 minus 12, so minus 8j. This is negative 3k. The second step, we just find a unit length, or that one, unit length vector, which is just push gradient of f as this one, these two, and I want to just divide it by the magnitude of that one. X is 2, y is 1, z is 2. Just divide the length, and then we'll have a unit length vector, right? So the top will be the same, it's just 2i minus 8j minus 3k, and divide the length. The length of this guy is just square root of 2 squared plus 8 squared minus 8 squared plus minus 3 squared. Okay, which is keep the same as 2i minus 8j minus 3k, divide by this whatever value we have. So this is a 4 plus 64 plus 9, so it should be 68 77. So that's it. So last question is compute the divergence curl of a vector field V given by this. Okay, the first compute divergence div of my vector field is given by, so let's say this is V1, this is V2, this is V3, for example. Now we can compute the divergence of curl. Okay, the divergence of curl. Divergence will be just partial the first one, V1, the first component, partial 3x squared z plus 2y over partial x plus partial 2x plus z over partial y plus partial x cubed plus y over partial z. Okay, so that's what we have. So if you compute that, now the first one is, you can see that all other variables are constant when you take a partial with respect to x. So here the first one is 6x times z. The 2y is gone because it's not a function of x. The second one, 2x plus z, is not a function of y, so it's 0. This is also 0, right? So it's gone, just 2xz. Curl b, which is given by, is also by computing the determinant of a 3 by 3 matrix. The 3 matrix is composed of 3 rows. The first row is always I, j, k. The second row is partial over partial x, partial over partial y, partial over partial z. So just put all, okay, let's make it a bit larger. So then you put all this v1, v2, v3, v1 and v2 and v3 over here. So by computation, you just put the number 3x squared z plus 2y. This is 2x plus z. This is x cubed plus y. When you compute that, you will have, which is I0 plus 0j plus 0k. Okay, I don't want to compute a determinant, just to compute that. Okay, you'll give 0 and 0, 0. Okay. Okay, so that's all for the midterm review. Let me know if you have any questions.